Hi, I'm Joe from JD Medical, and I am here to go over the JDM-SAFETY20 and JDM-SAFETY30 safety relief valve. The SAFETY20 is definitely the most popular valve, as you've probably already noticed. Under normal operating conditions, the 20 is going to be the valve that you're going to sell most and that operators are going to use the most. The 30 is generally reserved for use in either emergency situations where ventilators are common, or in certain surgical applications where you find a lot of ventilator use, so that the ventilator has a little bit more room to operate and you're not constantly blowing off gas in that 20 to 30 centimeter of water pressure range. So today we are going to, especially for demonstration purposes, focus on the JDM-SAFETY20. But the SAFETY30 is an optional product noted by the red valve and the inscription on the side that says 30 centimeters of water pressure. For reference, this has come up a couple times. Centimeters of water pressure is the common unit of measure for patient circuit pressure. Since PSI is probably the most common pressure indicator or unit that you guys, or that anybody is used to, but since the circuit pressure does not build up to the PSI range, centimeters of water pressure is used. So as indicated on the side, the valve will go up to and start blowing off at the inscription. This one is also denoted by the black valve, the JDM-SAFETY20, which will blow off at 20 centimeters of circuit pressure. The anesthesia machine here we have for demonstration is a JD Medical VT110. Operates the same as any anesthesia machine that you should find in the field. We've got the standard components: flow meter, manometer, circle absorber system with the directional valves, vaporizer, and the pop-off valve. For the demonstration purposes, I'm going to run through the general operation of the anesthesia machine without the safety valve in place, and then we will go through the occlusion valve, and then finally put in the safety valve and see how differently it operates under emergent conditions. So under normal conditions, the system will not build pressure while activating the flush or increasing the flow with the pop-off valve open. The pop-off valve open will let all gas through and not allow anything to build up. That quickly changes if the pop-off valve is left closed. We can hit the flush and build up pressure, and if the flow is on, we can increase that pressure and very quickly get into dangerous ranges where we're now causing trauma to the animal, significant injuries which may be permanent. Opening the pop-off valve will relieve that pressure, but by the time that increased pressure is noticed, it may be too late. Even a moment can be too much, and the animal may have permanent injuries. Many hospitals will have policies that say that the pop-off valve is never to be closed. That is a good policy that will increase safety, but it doesn't eliminate the possibility of accidental closure, equipment malfunction, or a service mistake where a service company may come in to do a pressure check during a yearly preventive maintenance or just an anesthesia machine repair and accidentally leave the valve closed. So accidental closures, equipment malfunctions are not going to be eliminated by a policy of leaving the valve open, or even in certain circumstances taping the valve open or fixing it so that it won't physically close. Service companies are certainly going to be closing that. One other way that people have attempted to eliminate the possibility of pressure buildup or having to close the valve is to add an occlusion valve. We have a version of that here. The occlusion valve is excellent for bagging patients and eliminating the possibility or the reason to have the valve open and closed all the time during normal operation. So if we leave the valve closed and we add in some pressure, we can build up pressure in there. You can bag, and if you forget and you have flow going, you can easily build up circuit pressures well into the dangerous range. Obviously this is eliminated by opening the pop-off valve. That eliminates the pressure, relieves it very quickly, but by the time you notice if somebody's forgotten, or in the event of one of the valves failing and having it stick closed, the damage has already been done. So that will eliminate certain circumstances, but nothing completely eliminates the possibility of either equipment malfunction or accidental closures and build up the pressure. That is where the safety relief valve comes in. So the safety relief valve is a pop-off valve that automatically opens up at a preset pressure. That pressure, under normal circumstances, on the most popular valve is 20 centimeters of water pressure. That's 20 on the manometer. The safety relief valve connects to any of the circuit connections on the anesthesia machine, but we generally recommend it be connected at the closest place to the exhaust. In this case, it is the inspiratory valve, and the exhaust connects to the exhaust of the anesthesia machine. If there is an occlusion valve, it should connect at the exhaust of the occlusion valve, not before the occlusion valve. So it should be the ultimate exhaust of the anesthesia machine coming in last to the exhaust, which will then exhaust out into the scavenger system of the facility. So insert the valve, give it a good twist for snug, and reconnect the patient circuit. Again, it can be connected to the expiratory valve if it's closer to the pop-off valve. In certain circumstances, you could even connect it to the bag. We don't recommend doing that because it's a little bit out of sight. It's good to be able to see that. So one of the circuit connections is preferred, but on some older or some strange anesthesia machines that may or may not be out there, it may be beneficial to connect it to another spot. But the valve needs to be connected to the patient's circuit and the exhaust to the exhaust. They're sized appropriately, 22 millimeter for fresh gas connections on the safety valve and 19 millimeter for exhaust, so they really should not be interchangeable without some serious effort. So we'll turn this back around, and now with the safety pop-off valve in there, if we build up pressure with the pop-off valve open, if we add gas in, it's not going to open because we aren't able to build up enough pressure. It's not functioning, it's not exhausting. If we close the pop-off valve, now is where we will see the valve function. So we'll build up some pressure using the flush, and you can hear the valve opening. So we bring it up above 20, and it will vent and return the machine to a safe pressure, making a noise so that you're alerted to a possible equipment malfunction or an accidental closure of the pop-off valve, giving you time to open the valve and relieve that pressure. If the valve is left closed and the flow meter's on, that pressure builds and it will pop off once it hits that threshold pressure, so you won't be able to go over that pressure. So we've hit a situation where it's venting the excess pressure that's being put into the system right now. That pressure is instantly relieved by opening the pop-off valve. Another situation where you could have a problem where the valve will vent is if the occlusion valve is held closed. We can build up pressure and it will vent pressure. In that case, it operates completely independently of the rest of the components of the anesthesia machine. If we add flow in, it will continue to vent, and I can release, if I've forgotten or if it's malfunctioned, the occlusion valve and relieve that pressure. One of the questions that we get a lot, which is a very good question, is manual resuscitation using the safety relief valve. If you hold the occlusion valve and you want to manually resuscitate the patient, I'm just going to build up a little bit of pressure here with the flush. You can still do that. The valve is not big enough to relieve all the pressure in the circuit, so it will still allow the circuit to build up plenty of pressure. If you want to hold the occlusion valve and give a breath, some gas will escape through the valve, but not enough to prevent the delivery of the breath to the patient. In prolonged use for resuscitation or for bagging the patient, you may have to supplement with a little extra oxygen flow, as over time more gas will be vented out through the valve in small increments every time that you squeeze the bag and it goes over that 20 centimeter threshold. But under normal bagging circumstances, it's not a problem to resuscitate using the valve and keeping that in place. The maintenance of the valve is virtually nothing, especially when it's connected on the inspiratory circuit, or inspiratory side of the circuit. If it's connected in the expiratory side, it's not a bad idea to let it sit. You can disconnect the circuit from it just to let it air out in case there's any moisture buildup. But if it's on the inspiratory side, you won't be building up any moisture in there, and it should stay just fine and operate fine for a very long time. But letting it air out is always a good idea. Disconnecting the circuit after use. And that's going to be especially important if it is connected to the expiratory side of the circuit. You do get a lot of expiration there with a lot of moisture, and it could build up in the valve over time. If you see any buildup in the line, or there is a particularly large dog that's exhaled a lot of moisture, it's always a good idea to it may be a good idea to empty it out if it does build up moisture on that expiratory side. And cleaning it, you can clean it like any other anesthesia component, rinsing it out, mild soap and water. We don't recommend any alcohol though. Alcohol is definitely bad for any component on the anesthesia machine, so no alcohol on that. But other than that, that's pretty much it. If you guys have any other questions, comments, problems, please let us know. We're always here to help. Again, I'm Joe with JD Medical, and thanks for watching.